Alright YouTube, you got me. Since you're underperforming all my other videos, I guess I'll have to reluctantly talk about Flat Earth once again. Flat Earth, Flat Earth, Flat Earth. Here's a video about Flat Earth.
Alright, so I want to talk a little bit about that phrase. That phrase that we get so often. You know, if it weren't for gravity, we'd all go flying off into space. As ridiculous as that sounds, there are still adults, supposedly rational thinking adults, that still say that exact same thing.
Oh yes indeed. There's a force that pulls us downwards to the ground. That force is called gravity, and without it you'd be flying upwards, which eventually I guess you'll just reach space. Now we can both agree that there is indeed a force that pulls you downwards, right? I mean, there's no denying that. The only difference is that you don't believe it's called gravity. You guys think it's density or some shit. And then there's a massive discussion involving gravity's influence on the Earth as a sphere and its interaction with celestial objects, which is what you guys really oppose, and now you're just against gravity in general, as if you're trying to debunk that force that keeps you on the ground. Well, you know, that force always existed. I don't see why you guys couldn't have just used the word gravity for it but disagree on what it does or something. That would be a lot simpler. Or would it?
The situation is that we've all been subjected to an extensive propaganda campaign that has resulted in people operating with total disregard for their own God-given senses.
Senses can be deceptive at times. Like that dress that's either black and blue or white and yellow. People see different things, so which is the right answer? Obviously it's black and blue, and if you say otherwise, you're objectively wrong and deserve to be put inside a mental institute. Okay, but for real though, you can't always trust your senses for everything. Do we assume microorganisms don't exist if we can't see them? Especially in science, it's important that we have special instruments to make up what we can't directly observe. So in this case, we invent microscopes. What about for the shape of the Earth? We develop telescopes and satellites. It's the same concept. Do not always trust your senses in science.
When individuals express their knowledge that they live on a flat, stationary plane,
He's a knowledge.
one of the most popular responses we get is in the form of gravity. So we were all programmed to believe in gravity, and we're told to respond by explaining gravity and saying that gravity is this amazing force on Earth that pulls everything towards the center of mass from all directions.
I'm surprised that you know what the center of mass is and its relation to gravity. Bravo! Although I can't confirm if you actually know specifically what it means, I'm gonna go with no until proven otherwise.
This infers that when people say that believe in a globe, that there exist people thousands of miles beneath your feet who are walking, driving, riding bikes, flying airplanes, finding love and loss, experiencing tragedy and hope, all while living their entire existence upside down relative to their position.
Ah yes, the upside down argument. It's not relative to their position. That statement literally doesn't even make sense. What you probably meant to say is, people in the southern hemisphere live upside down relative to the orientation of people living in the northern hemisphere. Look, I get it. It's difficult to imagine what it's like. But to them, they're the ones who are right side up. We experience the direction of up and down because of gravity. Because gravity pulls us towards one direction, and that direction is downwards for us, and the opposite direction is up. But anyway, just because you can't imagine it doesn't mean it's not true.
And what you're seeing here is a visual demonstration of just that.
That's kind of deceptive, don't you think? You'd be perfectly right side up if you were in that place.
A person can be standing next to a 4,000-pound vehicle and step outside said vehicle and stand next to a helium balloon while that balloon is attempting to float upward to the sky that is relatively beneath someone else's feet.
I know you guys don't like me going for low-hanging fruit, but apparently YouTube likes it. And you know how this works. YouTube's algorithm is everything. And frankly, I'm not happy about it either. Balloons with helium travels in the opposite of the direction of gravity due to low density of helium. Wait a minute, I hear you ask. That's exactly what flat earthers are saying. Density. Well, density itself can't determine the direction, you buffoons. Explain to me, flat earthers, why denser objects move downwards instead of any other direction. You can't, because gravity is the answer to that. You stick so much to this supposed, quote, common sense that you can't even answer the most basic questions because you can't see anything different than, well, obviously it's downwards. Well, why is it downwards? I'd love to hear your explanation for that.
People believe that gravity is strong enough to hold this 4,000-pound van to the ground because that's what you're seeing right here.
More massive objects produce a greater gravitational force, so it's easier to hold massive objects. Just like how it's more difficult for you to pick up a van compared to a candle. Gravity has a more forceful grip on it.
And then you're going to have these so-called experts on the internet who would shrug that off and offer up word salad, pseudo-scientific jargon.
Just because you can't understand it doesn't mean it's word salad.
To confuse people using terms like selective gravity.
Selective gravity? There's no such thing as selective gravity in physics.
But if gravity is the force that's keeping us all from flying off into space, then this would mean that there's some force, some repellent force that's either pushing everything away from the surface of the Earth, or that there's some force that's external to the Earth that's pulling everything away from the surface of the Earth in all directions, relatively. This would mean that there's some force that gravity's constantly in this eternal struggle with. Well, as far as we know, there's no repulsive force pushing everything away from the Earth.
In the science of stars, yes, gravity is fighting a force which is the pressure created by the nuclear activity in a star's core. The balance between the two prevents the star from collapsing or expanding into infinity. But if you're just talking about humans or objects on the Earth, then the story is different. Gravity is fighting a few small forces which really poses no match. The centrifugal force, for example, is a relatively small force that tries to knock everything on the surface of the Earth to space. Gravity very easily counters that. It's so funny because I've seen so many flat earthers say, well, centrifugal force should whip everyone into space. Well, the answer to that is gravity. And then now you're picking the other side of the straw and saying, well, what force is gravity fighting? Bitch, please. You know, the saying that gravity prevents us from flying into space doesn't even really say specifically that we would literally shoot off into space. It just means there wouldn't be a force that keeps us on the ground, so we would just float away. And if you push off against the ground at all, Newton's law states that you would just travel upwards. Unless, of course, something stops you. So yes, gravity is fighting, say, centrifugal force, but its main effect is that it holds you in place, so that you don't float around everywhere. No one is saying you would shoot the fuck up into space at whatever speed.
And as far as the external force pulling things off the Earth, that gravity's supposed to be constantly fighting against, well, some people would say that's the vacuum of space, and, you know, attribute all that to, you know, this infinite vacuum of space.
There you go. Gravity also plays a role in keeping objects and air molecules on the surface of the Earth, which supposedly, I guess, fights against the pressure differences between the Earth and space. So if gravity did switch off, everything would start seeking its equilibrium. Air would dissipate into space, the Earth would break off into chunks and float away. What's your response to that argument you set up for yourself?
But it's been demonstrated and it's been discussed at length by other content creators that the idea of an enclosed system existing next to a vacuum without a physical membrane or a barrier between the two, that's a physical impossibility.
Why does a barrier need to exist? What makes you think this pressure difference is enough to challenge gravity whatsoever? Let me put this into perspective for you. First of all, this so-called force is present due to differences in air pressure. Air tends to move from higher pressure to lower pressure. So why doesn't air just fly off into space, and as a result take everything with it, including humans and other objects? Well, the air pressure on Earth isn't the same throughout all altitudes. The higher you go up, the less pressure there is. So think of it this way. Gravity could indeed potentially lose to pressure differences. That's why you can suck air upwards through a vacuum cleaner. However, this multiple layer of pressure is what keeps things in place, and let me explain. It's a gradient. At the highest point on Earth, there's practically zero air pressure. This, compared to space, is negligible because the difference is so little. Gravity can easily counter that. Then, as you move downwards, it slowly increases. But no matter where you are, there will never be such a big difference in air pressure to give gravity a challenge. The so-called sucking force can only be strong if there is a huge pressure difference in immediate proximity to each other. But since the air pressure is like a gradient on Earth, getting less and less as you travel upwards, there's never going to be an incredibly high pressure right next to an incredibly low pressure. So that force is negligible when you compare it to gravity. And if there's no pressure difference to create that sucking force into the air, there's no air that can push you or other objects out into space. It's that simple. There's no barrier required.
So to summarize, if you believe that gravity is the force that keeps us all from flying off into space, then that means that there has to be some force that gravity is perpetually counteracting, that's either pushing us away from the surface of the Earth or that's pulling us out into space.
Disappointing. Disappointing, I say. Alright, I suppose I'll just end the video here. Wait, encore? Did I hear encore? Alright, fine, let's respond to another. No, nobody said encore. Literally nobody. Not a single soul. Not even yourself.
A selenelion is a total lunar eclipse that occurs when both the sun and moon are visible above the horizon. Of course, this is impossible in the heliocentric model, where the sun, earth, and moon must be aligned in a straight line so that the earth can cast its shadow on the moon.
You know, instead of just saying it's impossible on a globe Earth, how about you look it up? It takes 2 seconds to find this answer on Google. Selenelions can happen due to atmospheric refraction, which causes the sun and moon to both be visible at the same time. Their actual location is lower, and if refraction did not occur, it wouldn't be possible to see a selenelion. Luckily for us, we live in an atmosphere that can do all sorts of wacky things with light, and in this case, it makes the sun and moon appear higher than their actual location due to its ability to bend light towards the Earth.
Science articles about them use words like impossible.
Yup, they use the word impossible in quotation marks, and if you read further down the article, I'm sure it explains how it works.
Of course, then they go on to give their explanation of how this impossible event can happen after all. This illustration sums up the mainstream explanation quite nicely. As you can see, this happens because the Earth's atmosphere refracts light and the actual positions of the sun and moon are lower than they appear. But let's find out if it's really clearly explained. This guy's website goes on to say, as a result, the actual position of the moon is about half a degree lower than where it appears. So let's remember that half a degree discrepancy while we tweak this diagram a little bit. First, let's complete the circle of his Earth and put the sun and moon down here where they actually should be during a total lunar eclipse. Next, we'll get rid of his 50-mile tall guy and replace him with something more appropriate for this scale. And let's go ahead and put in a horizon line for our new smaller guy. He cannot see a single thing below this red line. How's that projected refraction theory holding up on the plausibility meter now that we're seeing it a lot closer to the actual story we've been told? And what was that he was saying about the actual moon and sun being only a half a degree lower than the apparent moon and sun? Yeah, he was about 43.5 degrees off.
Okay, so that diagram is most definitely just a rough image diagram sketch instead of accurately representing reality. It used a bigger person than usual, and the sun and moon are positioned to what we see from Earth, not from where their positions actually are. If you wanted this diagram to be accurate, the sun and moon would be many times bigger. They wouldn't be the small size that we see here. So, why don't we do that if we're going to take that direction? Yeah, let's scale it up. Oh, and while we're at it, we would also have to increase the distance. There's no way I could make it entirely to scale, so let's just arbitrarily increase it just to make it more accurate. Now, of course, they still wouldn't be visible at the same time if it weren't for atmospheric refraction. But do you see how this diagram isn't really the best to use here? The small sun and moon were used to put into our perspective, and from our perspective, they would be higher up like what we saw in the original diagram. The arrows there also just show that they're far away. You trying to make it realistic in turn made it more difficult to visualize. But then if you wanted it to be 100% realistic, then we would also have to increase the size of the sun and moon and the distance. Of course, what I put here isn't perfectly to scale, but it's accurate enough to give the right idea.
But we know the globe proponents will say that I haven't drawn the sun, earth, and moon to scale, and so my analysis doesn't count. Of course, this guy's diagram is just fine because it supports the mainstream narrative, right?
The reason I didn't grill the person who made this original diagram is because he's drawing the sun and moon based on our perspective, not to scale. The sun and moon appear to be that small for us, and the angle they're at is a good representation on where we see them. It's not deceptive, it's just drawn to perspective.
Let's not worry about the fact that refraction of this nature has never been scientifically verified. Sure, we've all seen the mirages on a hot road and the upside-down boats on top of the original boat, but nobody has ever witnessed a reflection, refraction, or mirage of something that couldn't itself also be seen at the same time.
Why does the quote, object itself have to be seen at the same time? What does that even mean? Take this light refraction in water, for example. We always see items in water in locations that are different than their actual location. That's refraction. This is seen in any body of water where the two mediums differ in their indexes of refraction. It's very similar to how the atmosphere refracts light, which differs depending on the density of air, which can be caused by a variety of conditions. There's nothing magical about that, it's just science.
We know from observational evidence that these atmosplenic distortions only occur when the actual object is also within our sight.
What? No? If you see a fish in the water, you're not actually seeing the actual fish, but rather an image of it that's location has been altered due to the water's refraction. What's the, quote, actual image of it that you speak of?
Anyway, while looking at this visual illustration of how selenelions work on a globe, let me give you the irrefutable proof that they can't. If the super tall man there is looking at a projected reflection of the moon right now, then the actual moon must have recently set. He is about to see the moon set for the second time in an hour. And if he is looking at a projected refraction of the sun, then he's about to see the actual sun rise within the hour.
No, you only see the refracted image. You won't see the sun or moon in its actual location, so you only see the moon set once and the sun rise once. When you see a fish in the water, you don't see two fish, and I think that's where your mistake comes from. You think that this apparent image is just another image we see on top of the actual image, but that's not the case. You only see the refracted sun or moon, that's it.
And who among us has ever observed 2 moonsets in one night or 2 sunrises in one day?
You're right, nobody has ever observed that!
Now ask yourself if you really believe that crap.
The only thing that this made me believe is the stupidity of flat earthers. Aw, don't cry. I know it's sad, but it's the truth. Here, look, I got this cup. Let me just slowly come over there. Slowly. Ever so slowly come and collect those salty, salty tears